Okay, dear student, now let's have another example. This time the example is about a composite signal. You can say the combination of two sinusoidals, and basically the signal involved here is x of n here. So what we are interested right now, we need to first of all check if the given signal is periodic or non-periodic, and if it is in this case, if it is for example periodic, then we can find the fundamental period here. So as we previously in the previous example, we found out that how can we check if a individual sinusoidal or a discrete time signal can be periodic or non-periodic here. Okay, so basically I will be using the same approach to find the value of n1 and n2, to find, like for example this is x1, to find the value of n1 from here and n2 by first checking if it is periodic and non-periodic, and then we can directly find n here. Okay, so what we have here basically, first of all, last time we said that, I mean the previous, we said that for the condition to check if this given sinusoidal is periodic and non-periodic, the ratio of omega divided by 2 pi should be equal to k by n here, and this k by n is nothing but these are two integers ratio, and once we have two integer ratio, it should be rational to make it a periodic signal here. Okay, so in this case, what is omega? Omega here will be equal to, let's suppose since we are talking about the first one here, so we can say this is n1 here and this is omega 1 here. Okay, like this, let's suppose this is x1 of n here, let's suppose this is x1 of n here. So now omega 1 here is 5 pi divided by 6, then we have multiply by 2 pi here, multiply by 2 pi here, will be equal to k divided by n1 here. So pi will be cancelled here, so we have 5 divided by 12, so k divided by n1 will be equal to 5 over 12 here. Okay, now this is a rational number, so we saw that this is rational, this is rational, so this is periodic in fact here. Okay, as per our previous discussion here. Now how to find n here? We just n1 will be equal to basically 12 here. I mean, you can see from here also n1 is equal to 12 here. You can also see from here, or if you want like what I'm doing here, n1 will be equal to, if we cross multiply, we are going to end up with 12 by 5. We'll end up with 12 by 5 k, and for k equal to, for example 5, n1 will be equal to 12 here. Okay, so up to you. I mean, you can use any approach here. Similarly, we do the same thing with the other signal. Let's suppose this is x2 of n here, and again, okay, this should be like basically square brackets here, so, but I'm writing the other bracket, so please assume it the same. Okay, as long as we have n, this is a discrete time signal. So omega 2 divided by 2 pi, let's suppose, will be equal to k by n2 here, and for k by n2, what is omega 2? Omega 2 is nothing but it is basically 3, this is 3 pi divided by 4 multiplied by 2 pi here. So pi is cancelled here, so we will have basically so k by n2 will be equal to, k by n2 will be equal to is basically how much? 3 by 8 here. Okay, so we get 3 by 8 here, and obviously we can use the same approach like what we did here, and we will end up with n2 will be equal to 8 here. Okay, I mean, in this case, we can assume that the value of k is equal to 3. So when k is equal to 3, we will have n2 is equal to 8 here. Okay, so now what we have basically, and also this was like the rational number, so this was also periodic here. So also periodic because this was the rational number here. Now we already got n1 and n2 here, so now we are interested in finding the I mean obviously basically this is the two periodic signals. I mean just one more thing here. We found that this is periodic and this is also periodic here. So the addition of two periodic signal will end up with another periodic signal, and we said that x of n is also periodic in this case. Okay, but still if you want to simplify it or if you want to check it, we can use the same approach like what we do here. We did like for example n divided by n2 here, and we can find the ratio. If this is a rational number, this will make it periodic, and obviously it will make the signal periodic here. Okay, so I mean obviously we will get basically 12 divided by 8, which will end up with if we divide with the 4, it will be equal to 3 by 2 here, and which is basically a periodic signal. Okay, so we also found that the n naught, like because we are interested in finding the fundamental period, so n naught will be equal to the least common multiple LCM of 12 and 8 here. And when you find the LCM of 12 and 8, you should get 24. This is what I got basically. Okay. So our fundamental, this signal x of n is periodic with the fundamental period n not equal to 24 here. Okay, just I mean one small hint here. I mean you should know how I find it. Okay, this is one way of finding it. You might have studied in another way. You can find it. Okay, so how we find the LCM here? We have 12 and 8 here. Okay, so we will start dividing it with the smaller number. For example, I start with the 2, so it will be like 6 and 4 here. Again, I can divide it with the 2, it will become 3, and 2 here. Again, I have individuals, so I can just say 2 is still 3, it will be equal to 1. Then I will divide with the 3, this will be equal to 1 1 here. Now we will multiply all of them here. So 2 multiplied by 2 is 4, multiplied by 2, 4 multiplied by 2 is 8, 8 multiplied by 3 is 24 here. Okay, so this is how I find the LCM here. If you know other method, and there will be other methods, and maybe you studied the other methods, please you can use it. Okay, the end thing is you solve it correctly and you end up with the same answer. Okay, so thank you.